this is kind of a closing of all the different things we've been dealing with looking at a function. So first, finding the derivative. Well, the derivative be 3x squared minus 12. I always think factoring, so I'm going to pull a 3 out. Factor some more. So this answers number 1. The critical points. Maybe I'll just put like a number 1 by it to show you this answers number 1. Okay. The critical points, whatever makes the derivative 0 or undefined, well, of course, that's going to be x equals 2 and negative 2. Okay. Classifying those, well, let's put them on a number line. I'm going to do that over here, right by the derivative. Okay. Now, if I plug in a number less than negative 2, say like negative 10, I get 3 times a negative times a negative. Well, that's positive. If I plug in a number between negative 2 and 2, like 0, 3 times a positive times a negative is negative. If I plug in a number bigger than 2, 3 times a positive is positive. So, the derivative changes from positive to negative. The function changes from increasing to decreasing. This is a maximum. Okay. If the derivative changes from negative to positive, the function changes from decreasing to increasing. This is a minimum. Okay. It says justify f prime changes from positive to negative. For minimum, f prime changes from negative to positive. Okay, so this answers number 3, this whole thing. Okay. Next, where's the function increasing? Well, of course, we're increasing when the derivative is positive. So we'd say, all right, we're increasing from negative infinity to negative 2, and from 2 to infinity, because that's where f prime is greater than 0. So that answers number 4 from up top. Okay. Number 5, we need the second derivative. Well, all right, let me kind of make a little box here of a workspace. The second derivative would just be 6x. Okay. To do a little sign analysis on that, so okay, this answers number 5, second derivative. To do a little sign analysis on that, the only point of interest here would be 0, because if we're looking for where the second derivative is 0, 6 times 0 is 0. Okay, if I plug in a number less than 0, 6 times a negative is negative. If I plug in a number bigger than 0, 6 times a positive is positive. So the inflection points for number 6, the inflection point occurs at x equals 0. I know that because that's where f double prime changes signs. Not enough to just be 0, it has to change signs. Finally, where's the function concave up? Well, it's concave up when the second derivative is positive, so from 0 to infinity.